All right, this lesson is about dividing polynomials. And this is the first example. It says divide this expression by the expression beneath. So if you're going to do that, we're going to use long division. So let's go back to probably third grade when you first learned long division. And you were probably given a problem something like this. 277 divided by 12. And you were told to call this 12. Then you have the divided by symbol, 277. And you ask yourself, how many times can 12 go into these first two digits? Well, 12 goes into 27 twice. So 2 times 12 was 24. You got here, and then what did you do? Right? You probably subtracted. Didn't ask questions, you just did it. So you subtracted those, and it was 27, subtract 24, gave you 3, and then you brought the 7 down, and you got 37. Then you say, well, how many times can 12 go into this new number, 37? You say, okay, 3. And then you said 3 times 12 was 36. All right? And then you remember that line, and then you subtract it again, the bottom number. Then you got this. Then you say, how many times can 12 go into 1? And you said, well, 12 can't go into 1. And then you first finished it by saying the remainder 1, right there on the end. So your answer was 23 with the remainder of 1. And then after a while, you realize, okay, I can rewrite that as 23. And I could take that remainder, put it over what I divided by. So it's 23 and 1 12. So I can prove it works, because I can say 12 times 23 and add 1 to it, and it should give me 277, which is what we began with. And that was long division. And that's what you did with regular numbers. We can do the same concept, the exact same concept, but in this case, it's going to be variables involved. So this is an example. It says x plus 2 is getting divided into this polynomial using long division. So I'm going to take my x plus 2, put it outside here, and then underneath the long division bracket is this numerator. So it's going to be 4x to the third plus 3x squared plus 2x plus 1. So your first question is, all right, I'm going to block this off a little bit from other stuff that's happening. So the first question is, x times what gives you 4x to the third? So you think x times what give me 4x to the third? So 4x squared works. So yeah, that works. So x times 4x squared, you multiply this to each one of those terms. So 4x squared times x is 4x to the third. And then you take it and you multiply it to the next number. So 4x squared times 2 is a positive 8x squared. The little line for equals, and then you got to remember to subtract. So I got to subtract everything, subtract both of those. So both of those signs change. Now these two should have opposite signs, so now they cancel out to be 0. And now I have positive 3x squared plus a negative 8x squared. Well, it's a negative 5x squared. And then these other things come down. So plus 2x plus 1. So now the question is, x times what should give me negative 5x squared? So x times what is that? Well, that's negative 5x. So negative 5x times x is negative 5x squared. I'm going to take this negative 5x and distribute it to the next number. So negative 5x times 2 is negative 10x. Then you got to remember, change their signs. So what was negative becomes positive, and what was positive becomes negative. So both of those signs change. So like clockwork, these cancel because you change their signs now. And 2x plus 10x is 12x plus 1. So then you say, well, x times what will give me a 12x? X times 12. So I'm multiply by 12. So I'm putting 12 on the end plus 12. Then distribute 12 to each one of these numbers. So 12 times x is 12x. And then 12 times 2 is 24. Change the signs. Change. You got 1, subtract 24. It's negative 23. I don't need that line. It's negative 23. And x can't go into negative 23 because it doesn't have x to go by. So that means this is my remainder. So our final answer here is when I divide this polynomial by this one, I'm left with this. I'm left with 4x squared subtract 5x plus 12, remainder negative 23. Or we call it 4x squared subtract 5x plus 12 plus negative 23 over x plus 2. Why x plus 2? Because that's what we divided by, and that's what the remainder is. So the remainder goes on top of what you divided by. This is acceptable answer. This is also acceptable answer. Just be honest though, as we go further and further along, we're going to eventually write more often like this, even though this is fine. Alright, so I'll go ahead and pause the video, copy down all of this as a note. I'm about to give you another one. And this time you're going to try to do it on your own before I actually explain it. So go ahead and pause the video and copy everything as a note. Alright, so this is a new example. Go ahead and pause the video, try it on your own first if you think you understand it. If you're not really sure, just go ahead and listen up. I'm about to explain it now. For everybody else who think they can give it a shot on their own, pause the video and then give it a shot and see if yours matches mine. Alright, so we're ready to give it a shot. This is what I do. I'll first write this part outside my division bracket, so it should be x squared, should be this. Alright, so I just took all the stuff underneath, in the back, and put it here, put stuff in the front underneath. Now the question is, x squared times what gives you 4x to the third? Well, you need a 4x. Alright, so 4x times x squared does give you 4x to the third. And that's your first number. How do you get the other numbers? You take the 4x and distribute to the first one, the second one, and the third number. So 4x times x, 3x squared, 4x times 3x should be a 12x, and then 4x times 1 should be a 4x. Alright, then change all their signs. So this becomes negative, this becomes negative, this becomes negative. Right? So add these up. These two add up to be nothing. 2x squared plus a negative 12x squared is a negative 10x. And then 3x plus a negative x is a negative 1x plus 5. Alright, now I'm going to create a new number. So now my number is x squared times what gives me a negative 10x? I'm sorry, this is squared and this is squared. So x squared times what gives me a negative 10x squared, right? So you think about it, negative 10. Alright, so let's get rid of this stuff I drew earlier. I got rid of it because now I'm going to distribute negative 10 to each number. The first one, the second one, and the third term. So negative 10 times x squared is negative 10x squared. Negative 10 times positive 3x is negative 30x. And negative 10 times 1 is negative 10. Equal sign, and then change all their signs. So this becomes positive, this becomes positive, this becomes positive. All the signs on the bottom row. Alright, so now when I add these, they cancel. And I get 1x plus a negative 1 plus 30 is positive 29x. 5 plus 10 is plus 15. So now the question is, x squared times what gives you 29x? Well, this is to the second power, and that's to the first power. You can't multiply x squared by something to make it go downward unless you're dividing. So we can't make it go downward unless we want to divide. So that's it. That's as far as it goes. So my remainder is 29x plus 15. So our answer for this, after I divide it, I'll write my answer to be 4x subtract 10 plus 29 plus 15 all over x squared plus 3x plus 1. And that's true. And that's what it is. You got to see some books take this bottom number, x squared plus 3x plus 1 that we divided by, and they're going to write this answer as 4x subtract 10 times x squared plus 3x plus 1 plus that remainder, 29x plus 15. And that 29 is x on it, up there. So 29x plus 15. So it depends on what author you're writing it, how they want you to write it. It could be written this way, where they'll write it as a factor and another factor plus remainder there and in like that. Either way is all true though. Like if you multiply this together, add a 29x plus 15, you will get back. You will get back what we began with. So that's it. That's true. All right. That's all. Got another note. All right. The next topic we're going to talk about synthetic division. Sometimes it's more useful to use synthetic division opposed to long division. However, sometimes you can't use synthetic division. Synthetic division can only be used for binomials down here. If I had a trinomial, like my last example, can't use synthetic division, so don't even think about it. But if I got a binomial or a binomial that's factorable, I might can use synthetic division, which is way easier. So this is how synthetic division works. This is a bracket we create. And in this bracket, outside here will be what makes the bottom number 0. So it's basically whatever makes that 0. X subtract 2, positive 2 makes it 0. So it goes positive 2. Make that look a little neater. And on the top here are all the coefficients. And the coefficient has to go in order 3, 2, 1 constant, as an x cubed, x squared, x to the first constant. This doesn't have an x to the first. So technically we'll rewrite it as 3x to the third plus 4x squared plus 0x to the first plus 10, all of x subtract 2. And I plug in a 0 there to hold the place of the numbers that are in the order. So my coefficients are 3, 4, 0, and 10. Now this is how it works. Take the first number, it comes straight down, 3. And then I'll say, okay, well, 2 times this number, 2 times 3, that's 6. Add this column. So 4 plus 6 is 10. And then I'll take 2 and multiply by this new number. So 2 times 10 is 20. Add these. 0 plus 20 is 20. And then 2 times 20 is 40. Add these, and it's 50. This last number is my remainder. Now, my new polynomial is going to be 1 degree smaller than I began with. I began with 3x to the third. My new polynomial is going to begin with squared. So it's 3x squared plus 10x to the first plus 20, remainder 50. Or you can put 50 over what you divided by. You could call that 3x squared plus 10x plus 20 plus 50 over x plus subtract 2. Either way is the right answer for it. You know, that's how you can divide using synthetic division. It's really nice to know that. It's really useful. It does save time. But you probably want another example, so let me give you one. Pause the video and copy all of this. I might give you one more synthetic division problem. All right, new example. So let's divide this. All right, so I'm going to first write my little brackets. And then the question is, the part at the bottom here, this question is, what do you divide? What's going to make this 0? So negative 5 makes it 0. Then the question is, does this go in descending order? Does it go 3, 2, 1 constant? Right? It skips to 2. So I got to say 2x cubed plus 0x squared plus subtract 6x plus 9. So know my coefficients are these numbers. 2, 0, negative 6, 9. All right. So the 2 comes down, makes it 2. 5 times 2 is negative 10. Add these, and it's negative 10. Multiply by 5, and it's positive 50. Add these, and it's 44. Multiply that by negative 5, and it's negative 220. And this is negative 211 as a remainder. And this is your final answer. That's all I have. Good luck.